Let's take a look at how we can plot data from a table and from a given model, whether it's linear or quadratic, in the same viewing window or on the same graph, and determine whether the model that we're given fits the set of data that we're given. So we can be given data in the form of an equation, and then we can be given another set of realistic data, and we can see if the two match. So the data that's in an equation is one that is theoretical, and the data that we may have gathered is actual data. So we want to see if the model actually is good for the real data. So let's take a look at how we would do that. We are going to use as our example from your pre-calculus text from section 1.2, problem number 87, which is on page 21. So we're just going to do the first part of this problem, and this problem is a quadratic equation. This one graphs in the form of a parabola. And this table shows the life expectancies of a child at birth in the United States for the selected years from 1930 through 2000. And those years are 1930, 1940, 1950, 60, 70, 80, 90, and 2000. And there are the life expectancies shown as y. The model given, as I said, is a quadratic, and y equals negative 0.002 t squared plus 0.50t plus 46.6. Now your domain is time t between 30 and 100. So you would set your domain as 30 and 100 inclusive, meaning you would include 30 and 100 in your domain. Y represents your life expectancy, and t is the time in years. T represents 30, and that corresponds to 1930. So when you enter in your data into your table, you would enter in 30 instead of 1930. So for each of these pieces of data in your chart, what I would do is go through and just convert each of your data values ahead of time. So this is going to be 30, this one's going to be 40, 50, 60, 70. So it's just an easy little switch here. 80, 90, and 100. All right, so there are your changes right there. So this problem tells us to use a graphing utility, and for our class we like always to use Desmos.com. Now you can use a different one if you like, but we like Desmos.com because it just does such a great job, and we've learned how to use that in class. To graph the data from the table being this right here, and the model that we're given is this right here. This is our model. And we want to do it in the same viewing window. And what that means is just do it on the same screen, do it on the same graph, and then determine how well does the model fit the data. So let's take a look at how we can do that. So we're going to go to Desmos.com, and I'm just going to open it up on the same page here. And we're going to do Start Graphing. So let's give it a minute to open up. So the first thing we're going to do, I'm going to go ahead and put the model in first, just because I just feel like doing that. And I am going to put y equals negative 0.002, and we need to use x because Desmos doesn't know about t. It just works in form of x and y. So we're going to do x squared plus, so whatever you're given, you want to work in x and y, okay? So, and then 0.50x plus 46.6. And then we need to tell it the domain, which if you recall, you need to put your brackets there, 30 and less than or equal to. X is between these values and less than or equal to 100, and close your brackets. And then see how we can't really see our graph. So remember, we can zoom out here so we can find it. There it is. It's way over there. There it is. Now we can find it. Okay, so now we need to put our table of values on here. But see, this is set up for an equation, so you need to use your drop down and give yourself a table in which you can enter in the values. So then you just start entering in your x's and your y's. Now your year would represent your x, that is your input, that is your domain. So 30, I think I just entered in 330 there. Got a little out of control. My y for that one would be 59.7. Oh, look at that dot. It landed right on my model that was already placed. My 40 and 62.9. Again, I'm right on the dot. So far, my data seems to be matching my model. 50 and 68.2. Well, that one didn't quite fall on the model, but that's okay. They're not all going to be exact. 60 and 69.7. Again, I'm back on the model. See how my little dots are showing up on the model here? They're all just showing up right there. Let's see, 70 and 70.8. I'm going to make sure you've got your ordered pairs right. 80 and 73.7. 90 and 75.4. And 100 and 76.8. Okay, so now you have your model and your points from your table graphed on the same graph. And you can see that yes, the model actually does fit this data quite well. Look at how all the points pretty much fall right on the line of that model. So yes, this model does fit the data very well. If it didn't fit the data very well, then you would have points just way off of the line. That's how you could tell that it didn't fit well at all. If you had points like maybe falling way up here and down here and over here, if your points were just all over the place and not falling on the same line as your model. Now, if you wanted to see the rest of number 87, if you wanted to see how the rest of these questions were answered, you could go on calcchat.com and you could look in section 1.2 at problem number 87.